Hello everyone. You. I'm Beatriz. I'm working on PMR. First of all, I want to thank the Trump Foundation for the Cyber Award to present my work. Here is about assess the heat stress in Madrid using modeling techniques. And the study is based on analyze the past and future changes in the spatiotemporal distribution of heat stress in Madrid. These results are part of the Spanish project with my other colleagues in Human and also another Spanish institution. Well, as we all know, the global temperature has increased during the last few decades, being faster since 1970. We also know that the proportion of the world population living in cities has increased, in particular since 1970 from 30% or 40% to 60%, and it's expected to continue rising, which entails a rapid urbanization because of we increase the urban land cover and also the infrastructure, leading to exacerbate the urban overheating. These warming trends, therefore, are influenced both by the large-scale climate processes and also by the local-scale urbanization. This, as we also see in the news every year, has an impact on human health, on the city, the city dwellers, and there are several comprehensive heat stress indices to define and quantify this interaction between weather variability and also the current body response. Here in this study, we focus on the Universal Climate Index. So our research question is to analyze how the urban expansion or the climate variability have affected population heat stress over the past 50 years. And also, we wanted to analyze using this modeling, this numerical simulation, what can we expect under the future scenario. So our objective is focus on Madrid city, and also during the summer condition is during a month in July. And we analyze the past 50 years and also a future scenario. We selected Madrid because it's located in the center of Spain. We selected this city because we observed there is an increase on the air temperature in the reference station, which is, if you see the outside the black line, is the region of Madrid, and the small black line is the city center of Madrid. And here we have the population has, during the last 60 years, we observed that the population has doubled. However, the urbanized areas has increased up to 5 factor of 5. So that's why we selected this city. The blue areas in 1970 is how the city was in this year. And at the bottom, we see how the urban expansion has increased in 2020. So we use the mesoscale model, which is world research and forecasting model, the world model. And here we are using the urban scheme parameterization and the latest development, which is the world conform parameterization. With this parameterization, we can calculate the UTCI index and also its variability per grid cell. So our resolution is about 1 kilometer per 1 kilometer, and within one grid point, we can obtain 54 values for the UTCI index. So we can know the depth percentile of the coolest spots in the grid cell, and also the 50 percentile and the 90 percentile to obtain different values of the UTCI index per grid point. So to analyze the impact of the urban expansion and also the climate, we have we have three different scenarios. The first one is the best case, where they consider the variability of the climate since 1970 to 2020. I have to say that we are only simulating 1 month, which is July. And instead of doing the decade, we selected the representative year per decade. And we simulate that July. And that is where we change it to analyze the climate variability and also the urban expansion. To include the variability of these urbanized areas over these decades, we consider these scenarios in 1970, 80, 90. So we can see how this Madrid city has increased and surrounding has increased over these years. And the latest scenario with the expansion of 2030, we use the future climate projection to calculate the UTCI value. What we did first was to evaluate the model first with the minimum, maximum, and the mean temperature in two stations, one rural and one urban station. We observed that we obtained a good agreement with the observation and also with low errors. So we have confidence with this on this simulation. And this is the first results. So this is the mean map, the monthly mean maps. In this case, I selected the UTCI, the 90th percentile of the UTCI index, which is representing the hotspot per grid cell. We see that since 1970 to 2020, we observed the increase of the UTCI index from especially in the city center. And if we do the average, the spatial average, we obtain that in all the spots, all points within our grid cell, the increase is around 5 degrees for the UTCI index. If we analyze which is the contribution of the urban expansion, we observe that that contribution is less pronounced. But if we calculate the differences of this year respect to 1970, we observe that the increase of the UTCI index caused by the urbanization in this area, in the city center, is around 1.3 degrees. This is our monthly mean values. We also observe that these differences in the UTCI index are irregular over the area, the urban area, and this can be up to 3 degrees, depending on which area or which grid cell we observe. So that's why we selected different points. There you can see there a map with 3 points. Here I want to show you only the result of 2 points. One is point 1. If we see the graph below, the urban fraction, we selected this point because the urban morphology and the urban expansion didn't change over time. So we observed that urban fraction is 1, it's a very urbanized area, it's also a compact area because the aspect ratio is above 1. So it means it's a narrow streets and also very compact, very density area. And the third point, because I'm going to focus on the point 3, which is at the north of Madrid, is the green line. And in 1970, the urban fraction increased from 0.3 to almost 1 degree, or 1 or 0.9. So there was an urban expansion in this area of the city. So if we analyze the base case where we are simulating the variability of climate and also the urban expansion, we observe the temperature increase at these points, but we didn't observe a very significant difference between this point in temperature, in air temperature, because of the morphology. However, if we focus on the UTCI values, I'm comparing purple line with green line. The increase in point 1, we observed that since 1970 to 2020, the UTCI values increased up to 4 degrees. However, in the point 3, that increase is 2 degrees more. So that's why we focus on this point to analyze the increase of the UTCI values and also the impact of the climate. So at the top is the diurnal cycle of the UTCI index in the base case, and at the bottom is the urban expansion impact. In both cases, we observe that the difference is, or that increase in the UTCI index over the past 50 years is between 6 p.m. to 7 p.m. Except for the base case, where the largest difference, where we observe there are significant differences during the daytime. And we can also see that this hotspot, the UTCI index in this hotspot, has changed in the categories of the UTCI values. That's why we analyze the frequency, how this of the number of hours and different categories of heat stress has changed since 1970. We observe that even if the urban morphology doesn't change over the past 50 years, we observe that in the first graph at the top, the number of hours on the thermal heat stress and the non-thermal heat stress has decreased over time around 30%, and also the temperature, the value of the UTC index has increased 2 degrees. If we also see this influence in the in point 3, where the reduction of the number of hours on the non-thermal heat stress is less, but the increase of the UTCI index is up to 3 degrees. We see more or less the same trend because of the urbanization, but it's true that the contribution is lower than taking into account not only the urban expansion, but also the climate. And the last thing we observe is that the exposure to very strong heat stress increases since 1970 to 2020, and the UTCI values are slightly higher than 50 years ago. So these are the results. We are here comparing 2020 with the future projection. And this is only for the point 3, where in this case, the urban expansion doesn't change. So we are considering only the impact of climate in the UTCI index. So under this scenario, we have that the temperature, the average increase of air temperature for minimum and maximum is around 5-6 degrees using this scenario. And if we observe the frequency of how many hours are under different categories in 2020 and under a future scenario, we observe that more than 50% of the hours will be classified under strong, very strong, or extreme heat stress, but not only for the hotspot in our grid point, but also for the 10 percentile and medium percentile, which means that points which are in the cool spot in our urban grid. So another thing, the finding that we observe is that there is a significant decrease in the of the non-thermal heat stress frequency, which is under lower that decrease is about below 30% of the hours per month in the future scenario. So from this preliminary study, we can conclude that there is a good agreement of the model temperature, so we have certain confidence to use this model configuration for Madrid and the future scenario. We observed that there is a significant increase of about 5 degrees in the thermal comfort index, being less pronounced, being the contribution of urban expansion being around 1 degree, 1.3 degrees. We observe that there is more influence of the urban morphology on the UTCI index than on the mean temperature. And finally, we observe that there is a significant decrease of the number of hours with no thermal heat stress, and the UTCI values are going, the magnitude is in this range with and without urban changes increased over the past 50 years. And for the future scenario, we observe that there are more hours, more than 50% of the hours during this month will be classified under very strong or extreme heat stress. So these are the preliminary results of a Spanish project that just started, and the objective of doing this simulation and using numerical techniques to calculate this thermal comfort index is to calculate vulnerability heat maps and analyze and explore different impacts on mitigation strategy to see which areas of the city needs more studies will implement mitigation study and which kind of mitigation study we need for this area.